Welcome. For those of you in my calculus course, this is the last of the videos on centroids. So suppose R is the region bounded above by this parabola, that's 2 minus x squared, and then it's bounded below by y equals x. Let's find the centroid of this region. And we're assuming a uniform density throughout. So I'm going to begin with a sketch. Clearly, I think you should begin with a sketch too. All right, so here is the sketch. And as you can see, we have a couple intersection points. Pause the video and take a moment and figure those out algebraically. Okay, so these are the intersection points you should have gotten at -2, -2, and 1, 1. And then our region is here. All right, so let's begin by finding the area of this region. So we're integrating from -2 to 1, and the upper function is 2 minus x squared, and the lower function is x. So this is just the integral from -2 to 1 of 2 minus x squared minus x. And I guess I really could have skipped that step. So this is 2x minus x cubed over 3 minus x squared over 2. And we're integrating from -2 to 1. So this is 2 minus 1/3 minus 1/2 minus -4 plus 8 over 3 minus 4 over 2, which is just 2. This should work out to be 9 over 2, but I'm doing this kind of quickly in my head, so if you get a different value, let me know and I'll fix this video eventually. So A is equal to 9 over 2. And since both of the integrals that we're going to use to find x bar and y bar have 1 over a in front, let's work out what 1 over a is. Well, that's just a reciprocal. That's 2/9. So I'm going to shrink this down now and make some space. So let's go ahead and find x bar. That's equal to 1 over a times the integral from a to b of x, f of x minus g of x dx. In this case, this is our f, this is our g. 1 over a is right here, a is here, b is here. So this works out to be the integral from -2 to 1 times 2/9, of course, of 2x minus x cubed minus x squared dx. So that's 2 over 9 times x squared minus x to the 4th over 4 minus x cubed over 3. And that's from -2 to 1. Take a moment, pause your video, and finish working this out. You should have -1/2. So for y bar, we're going to take a similar approach here, but we're going to start with 1 over a, which we've already worked out, and this is the integral from a to b of f of x squared minus g of x squared dx. So this is 2 over 9 times the integral from -2 to 1. Our f function is the upper function, so this is 2 minus x squared minus the lower function, which is just x squared dx. So I'll work out just a little bit more of this algebraically. So this is 2 over 9 times the integral from -2 to 1 of 4 minus 5x squared plus x to the 4th dx. Pause your video if you don't see how I got from here to here and try this out, and then keep it paused and work out what number this is, since by now you should definitely be able to work out integrals like this. Now that you've paused your video, worked all of this out, you end up with 4/5, and that's 0.8. I'm going to write this one out as a decimal as well. And why am I doing that? Well, our center of mass is located at x bar, comma, y bar, and that is negative 0.5, comma, 0.8. Let's see if we can figure out visually where that is. This number here is about 1.4, so this is about negative 1.4. So that gives me an idea that negative a half is about here. This would be 1, so 0.8 would be about here. So our center of mass is right there in that nice spot. And that looks pretty good. If we were to balance this plate, this is where its balancing point would be, its center of mass. I hope you found this video helpful.